In this video, I introduce a maximum mean discrepancy in machine learning. Maximum mean discrepancy determines if two samples are from different distributions by mapping distance between the means of two samples into a reproducing kernel Hilbert space. Suppose that curve f is a class of function f, p and q are distributions on a domain x. Given ID observations x and y drawing from P and Q respectively, we convert the comparison between P and Q into the comparison between their samples x and y. MMD and his empirical estimate is defined as a superior amount of mean discrepancy. This is the population MMD and his empirical estimate. We express MMD as a more easily computable form. In a reproducing kernel Hilbert space F, function evaluation can be written as the expectation of phi and f, where phi is a kernel function. The expectation of kernel function phi over distribution P is denoted as mean is equal to expectation of kernel function phi over distribution P. Using this formulation, we may rewrite the MMD as the superior amount of this mean discrepancy and F. That is equal to mean discrepancy in reproducing kernel Hilbert space. Using definition of mean and kernel function in empirical estimate of MMD is equal to sum of three terms. First term, the x sampled from distribution P. Third term, the kernel function sampled over the distribution Q, and the second term, the kernel function sampled over the distribution P and Q. MMD is a test statistic for P is not equal to Q. However, is biased due to the upper bound. MMD is small if P is the same as Q, and is large if the two distributions P and Q are far apart. We now derive unbiased MMD formulation given x and x prime independent random variables with a distribution P and y prime independent variables with a distribution Q. The population squared MMD is a summation of three expectations. First term, the kernel sampled over distribution P. Third term, the kernel sampled over distribution Q. And the second term, the kernel sampled over the distributions P and Q. Defining Z as MID random variables, where Z is equal to X and Y. Unbiased, the empirical estimate of squared MMD is defined as a sum of function H, which is one sample unbiased statistic with function H is equal to sum of four kernel functions. Given two samples, X and Y, from two distributions, P and Q, and select the kernel function key, we can use MMD to compute the MMD distance between the two distributions, P and Q. For more details, please check with these references. Thank you. Bye.